In the last video, we learned how to find the least common multiple of numbers by prime factoring each one, well, prime factoring them together. In this video, I want to start by prime factoring those same numbers individually, just so you can see how the LCM, or the least common multiple, relates. So remember, to prime factor a number, we take the smallest prime number that can evenly divide into it. That's 2. 36 divided by 2 is 18. 18 can be divided by 2 again. That leaves me with 9. 9 cannot be divided by 2, so that'll be 3. 9 divides by 3 3 times, and 3 is divisible by 3, and I know that I am done when I divide and the last number I have is a 1. That tells me that I'm done. So 36 is 2 squared times 3 squared. Well, let's take a look at 48. 48 is also 2. Leaves me with 24. 2 again. You should be doing this in your head or on your paper as we're going along. 6. 2 again. And that leaves me with 3. And 3 doesn't divide by 2, but it does divide by 3. And that tells me that I'm done, because 3 divided by 3 is 1. This 1 is pretty magical. Remember, all numbers are divisible by 1, so when I get a 1 at the end, that's how I know I'm done dividing. So, in essence, 48 is 2 times 2 times 2 times 2. That's 2 to the 4th power times 3. And this 3, remember, because there's only one of them, it's to the 1st power. So what we have to understand is that when we find the least common multiple, remember we said in the previous video that the LCM was 144. So how do we know that? How do we glean that information from the prime factors? The first thing we have to do is take each prime factor that occurs in all of the numbers. Well, both of them have a 2, and both of them have a 3, and there's no other number that either of them have, so really it's going to be a power of 2 times a power of 3. And what we want to do is find the highest exponent that occurs in each number, in all the numbers. See, this one is 2 to the 2nd power, but this one is 2 to the 4th power. So I need to use that highest exponent. And this one is 3 to the 2nd power. This one is only 3 to the 1st power, so I'm going to use 3 to the 2nd power. So in essence, what we have is 16 times 9, or 144. So remember, we need each individual factor, all the different factors that occur, and we take the highest power of each one. That's how we get the least common multiple. Now, I spent a lot of time on talking about numbers because when we do rational expression, it's essentially the same thing. 12xy squared. Let's compare that to a number, 8 over 15x cubed y squared. So in this one, there is a number part and 2 variables. I have an x variable there, and I have a y variable here and here. So let's do the number part first. The number part is 12 divides by 2 divides by 6, 2, 3, 3, and then I'm done. So it's 2 squared times 3. 15 is 15 divides by 3, leaves with 5, divides by 5, and that's 1. So 15 is 3 times 5. Now, remember, we're talking about the highest power of each individual. So the LCM here will be 2 times 3 times 5, or 2 to the 2nd power, because that's what we have. Both of those are 3 to the 1st power, and 5 also to the 1st power. Now, they will have the highest power of my x's, which will be x to the 3rd, and the highest power of my y's, which will be, both of them are y squared. So that number is 4 times 3 is 12 times 5 is 60. 60 x to the third y squared. This now is the LCM of these two fractions. Now, knowing that we start looking for the LCM by factoring, I'm wondering if you can tell me how to find the least common multiple of x squared plus 2x plus 1, 5x squared minus 5x, and the quantity x squared minus 1. If you can find the common multiple, what is the LCM of these three factors, please leave it in the comments and tell me what your strategy was for getting it.